Formal charge is an electron bookkeeping method that we will use to assign a priority to multiple possible Lewis representations for molecules. To start, just as an example to show the steps in how to calculate formal charge, we will use the nitrate ion. Nitrate has this Lewis structure, which we've done previously. You can see that it has a double bond between nitrogen and oxygen and two other single bonds. We've already talked about how this actually has multiple resonance forms that are equivalent to this representation shown. However, we will just use this one because in multiple, as long as your multiple resonance forms are actually equivalent, the formal charges you calculate will also be equivalent. So we will just use this one as our example. Formal charge is calculated for each atom in the molecule or ion. So we will calculate formal charge for all three oxygens and the nitrogen in this ion. And the formula is that formal charge equals the number of valence electrons for the free atom minus the number of lone pairs of electrons on that atom in the molecular ion minus 1/2 the number of bonding electrons on that atom in the molecule or ion. And this essentially works out to be the number of valence electrons minus what I call the number of electrons that the atom in that molecule owns. So oxygen, for instance, in nitrate, the left oxygen on the far left over here, this atom has full control of the lone pairs because it doesn't share those with anybody else, with any other atoms. However, the bonded pair right here, it shares, right, with the nitrogen. So it only really has control over, say, one of those electrons in the bond, and so it only gets counted once, as in the rule here. Okay, so let's go ahead and put this into practice. We'll calculate the formal charge on oxygen number 1, and we find that oxygen, if we look in the periodic table, counting from left to right to oxygen's position, we see that it has 6 valence electrons, minus, in this case, it has 3 lone pairs, and there's 2 electrons, of course, in each pair. So that's a total of 6 electrons for lone pairs, so 6 minus 6. And then finally, for the bond, we get 1 electron, right? Because 1/2 times 2 electrons in the bond is 1. So 6 minus 1 is -1. And so the formal charge on this oxygen is -1. Now, I'm going to point out and make a point here to say that this oxygen does not technically have a -1 charge. This is simply a bookkeeping method to help us to distinguish between different types of structures that are possible. And I'll show you how to use it for that purpose in the next slide. But for now, just make sure to keep in mind that there's not actually a negative charge necessarily on this oxygen or in any other atom or on any other atoms for which we calculate the formal charge. Okay, so now let's move on to this oxygen number 2. Since it looks exactly like oxygen number 1 in terms of its environment, it has the same formal charge, so we'll just go ahead and write -1 next to that one. For oxygen number 2, oxygen number 3, now we have a formal charge of 6 valence electrons for that oxygen, minus we have 2 sets of lone pairs, so that's 4 lone pair electrons around that oxygen. It has 2 bonds to it, which it shares with the nitrogen, so 1/2, right, times the 4 electrons in those bonds would be 2, and 6 minus 4 minus 2 is 0, so the formal charge on that oxygen is 0, no formal charge. Now moving on to the nitrogen. Okay, the formal charge on the nitrogen in this, well, nitrogen has 5 valence electrons, It has no lone pairs around it, so we have a 0 contribution of electrons in lone pairs. And then finally it has 4 bonds, right? So in each of those bonds is 2 electrons, so that's 8. 1/2 times 8 is 4 electrons total that the nitrogen has from bonding electrons, so minus 4, and that leaves plus 1, so the formal charge on that nitrogen is plus 1. And that is how you calculate formal charge on atoms in a molecular ion. You may have noticed that the formal charges on the nitrate add up to be the total charge for the ion, and that's the case for all molecules and ions. The formal charges will always add, if you've done it correctly, to give the total charge on the molecule or the ion.